Just imagine a place where physics starts to break down, where the laws of the universe feel like something straight out of a sci-fi movie. In this place, time and space get warped to levels even science can't fully explain. Yep, we're talking about black holes. Those gigantic, mysterious points in the universe that suck in everything around them, including light, leaving scientists everywhere scratching their heads. In this video, we're diving deep into the enigma of black holes to explore what we know and what nobody has yet managed to explain about them. So get ready, because this journey is going to be a long one, and who knows, maybe there's no turning back. So first things first, what exactly is a black hole? In simple terms, it's what's left when a massive star goes supernova and collapses. When a huge star dies, it implodes, creating a gravitational field so intense that not even light can escape. Imagine the star being crushed into a point with infinite density, and that's how a black hole forms. This central point, where gravity and density become infinite, is called the singularity, and that's where the real mystery kicks in. The singularity is so bizarre that it challenges everything we know about physics. It's like the universe saying, from here on, science is out of ideas. Before reaching the singularity, though, there's a sort of no-return zone around the black hole, the famous event horizon. Think of it as a one-way gate. Once you cross that line, there's no escape. Anything that crosses this boundary gets pulled into the black hole, where nobody knows for sure what happens next. And that's why black holes are black. Even light can't get out. Now, you might be wondering, didn't Einstein explain all of this? Einstein's theory of relativity does explain a lot about how black holes work, but only to a certain point. Once we get to the singularity, all the rules we know collapse. It's like Einstein himself left a note saying, "Beyond here, I'm stumped." And that's why black holes are still one of the biggest mysteries in physics. In this realm, the laws we know just stop working. Picture this: you're out in space, exploring in your spaceship, living the adventure of a lifetime, when, oops, you fall into a black hole. What's the first thing that happens? You start stretching out like spaghetti. No joke. This phenomenon is called spaghettification. And yes, that's a real scientific term. But wait, beyond turning into human spaghetti, there's an even bigger mystery. If a person or anything falls into a black hole, where does all the information about it go? In theory, physics tells us that the information about an object can't just disappear, but black holes seem to ignore this rule. This is the famous information paradox, one of those puzzles that still keeps scientists up at night. And the questions don't stop there. There's even a theory that some black holes formed right at the beginning of the universe, just after the Big Bang. These are known as primordial black holes, and they're different from normal black holes because they weren't created from dying stars, but from the chaotic, extreme conditions of the early universe. Even crazier, some primordial black holes might be incredibly tiny, as small as an atom, but with the mass of a mountain. And if they do exist, where are they? No one's ever found one, but it's yet another mystery that keeps scientists intrigued. And then there are the supermassive black holes. Yes, some black holes aren't just big, they're colossal. And where are these giants? Right in the center of galaxies. That's right, at the heart of nearly every galaxy, including our Milky Way, there's a supermassive black hole. But how did these cosmic monsters get so big? Did they grow over time, devouring everything nearby? Or were they born supermassive from the start? This is yet another unsolved question that scientists around the world keep studying. And if you think black holes only mean darkness and emptiness, think again. Despite being black, they can also be the brightest objects in the universe. Here's why. When a black hole starts consuming matter, it creates an accretion disk around it, like a ring of material spinning and heating up. This disk emits an insane amount of energy and light, creating what's known as a quasar. A quasar is an explosion of light and energy so intense it can outshine an entire galaxy. Yes, a black hole can be so powerful that its light can be seen from billions of light years away. The most amazing part is that these quasars, aside from being spectacular to our telescopes, are essential for scientists to understand the structure and evolution of galaxies. Every time a quasar is detected, it becomes like a time machine, giving us a direct glimpse into the universe's past. The light from the quasars we see today was emitted billions of years ago, when the universe was still young. So studying these phenomena lets us peek into what was happening in the cosmos way back at the beginning of everything. They're like an open cosmic diary for anyone curious and equipped with the technology to read. But hold on, the complexity of black holes doesn't stop there. There's a strange phenomenon tied to black holes that still sparks lots of debate among scientists: gravitational waves. Basically, when two black holes collide, they create ripples in the very fabric of space-time. Imagine throwing a rock into a pond. It creates waves that spread out. Now, imagine that rock being two black holes merging, and the ripples being waves in the fabric of the universe itself. Well, in 2015, scientists finally detected these gravitational waves for the first time. This discovery was a major milestone for science, but it also left us with more questions than answers. How do these waves affect the universe around us? And what can they reveal about black holes and space-time itself? Now, let's talk about something that sounds straight out of a sci-fi movie: wormholes. Though they aren't exactly black holes, they are directly related. The idea goes like this. Some scientists theorize that, under certain conditions, a black hole might connect to another point in space-time through a tunnel. This tunnel would be what we call a wormhole. In theory, it could allow someone or something to travel from one point in the universe to another in the blink of an eye. The problem? No one's ever proven that wormholes actually exist. And honestly, stepping into one of these might be a one-way trip. While the idea is fascinating, it also reminds us that the universe still holds mysteries far beyond our comprehension. Another fascinating point about black holes is their relationship with time. Have you heard that time moves slower near a black hole? This happens because of the extreme gravity around the event horizon. If someone could stay close to a black hole without being destroyed, they'd notice that time moves much slower for them compared to someone farther away. It's like being in slow motion compared to the rest of the universe. And this isn't just theory. This effect was confirmed by Einstein's theory of relativity, and it's one of the few things scientists do understand well about black holes. And this brings up another question that's far from being resolved. Could black holes somehow allow time travel? It might sound absurd, but many physicists consider that the intense gravity of a black hole could create a curve in space-time so extreme that it might, in theory, allow a kind of passage between different times. But hold your horses. Before you start packing for a trip to the past or future, remember that this is just a hypothesis, and the level of technology and understanding we need to make it happen is far beyond what we currently have. Lastly, there's an intriguing question that still stumps physicists. Do black holes have an end? In other words, what happens to a black hole over billions and billions of years? This question started being explored when Stephen Hawking, the famous British physicist, proposed what's known as Hawking radiation. According to him, black holes aren't completely black, after all. They emit a very faint, slow radiation, which means that gradually they lose mass. In theory, a black hole that stops feeding on surrounding matter would eventually evaporate entirely over time, except we haven't been able to observe this yet. Hawking radiation is so weak that it's still out of reach for our instruments. And if black holes really do evaporate, that raises another question to bring us full circle. What happens to all the matter and information that a black hole devoured over its existence? Does all that information somehow return to the universe? It's like each answer brings up a new question, and each discovery unveils a fresh mystery. That's why black holes are like the universe's ultimate enigma. They challenge our theories, our certainties, and remind us that the universe is a far, far more complex place than any of us could ever imagine. If you've made it this far, congratulations. Because understanding black holes is like trying to grasp the essence of the universe itself, and yet always being met with more questions without answers.